Hey there, Science 20. We're going to keep looking at calculations that don't involve graphs and um, just how to know when we would be using them, etc. When we look at uniform motion, the distance or displacement that's covered in each second is going to be the same. This isn't going to be the case in non-uniform motion or when we have acceleration. So in the case of uniform motion, the velocity is going to be delta d over delta t. Uh, and you can rearrange that in this way to calculate for the displacement. But if we have non-uniform motion, we have two options available to us. The first option is this formula here, Vf plus Vi over 2 times t. That, by the way, should be a delta t. Um, but the uh, oh, but the displacement here, you're not given a final velocity, but you are given an acceleration, and so you would use this formula of initial velocity times change in time plus 1/2 of the times the acceleration times the change in time squared. So this is why it's really important to identify what variables we have. So in this case, uh, in the case of the logging truck accelerating from 10 meters per second to the right to 20 meters per second to the right, we've got ourselves an initial velocity, a final velocity, a change in time. We're looking for the displacement. So this is the formula that we're going to use. Uh, Pretty easy to add this in here at that point. And then that's going to be divided by 2, multiplied by the change in time, which is 5 seconds. Sorry, 5 seconds, 5.0 seconds. When we look at our average velocity, that's 10 meters per second plus 20 meters per second is 30. 30 divided by 2 is 15 meters per second. We're going to multiply that by 5 seconds. Seconds cancel each other out, so the only units we're left with is meters. And when you put in your calculator 15 meters per second times 5 seconds, you end up with, to 2 sig digs, 75 meters. So great stuff. In our acceleration formulas, we've got acceleration can be used in a few different ways. But for these calculations that you're going to be doing, again, important that we know what our variables are that we are given and what units we're going to be using. And so let me just write these down here, what the units are going to be. This is just basic. Hopefully we know all of this by now, and it's given in your data booklet anyways, so we don't need to worry too much about it. But coming to some of these practice problems, let's work through this one first here. We're told that a cement block falls from the roof of a building, and it takes the block 5.60 seconds to land what is the displacement of the block, assuming an initial velocity of 0 meters per second. In other words, we're holding this cement block and then we're letting it drop. So our initial velocity is 0 meters per second. Our change in time is 5.60 seconds. Our acceleration is going to be, this is really messy here. Our acceleration is going to be 9.8 meters per second squared. And you know what? I'm just going to show you this on just a separate, instead of restarting the video. I'll just show you what it would look like. So delta t was 5.60 seconds. Acceleration, because it's being dropped, that's acceleration due to gravity, 81 meters per second squared. I just want to just double check and make sure I got all the information from all of that. And because we're going down, normally we would say moving up is in the positive direction and moving down is in the negative direction. So this would be a negative 9.81 meters per second squared. And what are they asking us for? They are asking us for the displacement of this object. Now, of the different equations that we could be using, in this one here, this doesn't even look for a displacement, so we can't use this one. This one we're given an initial velocity, but we're not told what the final velocity is. So this equation isn't going to be useful for us. The third equation, we are told what the initial velocity is. We're told the change in time, and we're told the acceleration. So this becomes the equation that we would use. So change in displacement equals VI times change in time plus 1/2 acceleration times change in time squared. Okay. Our initial velocity is 0 meters per second. Anything times 0 is going to be 0. So we can just kind of abbreviate that because this is 0. This will be 0. So we're going to add 1/2 times negative 9.81 meters per second squared times 5.60 seconds squared. Okay, so got my calculator out. 1/2 times 9.81, and that's a negative 9.81, times 5.6 squared is going to give us negative 153.8208 meters. Now, sig digs, we'll just say that's 0.0. There's, I'm going to go 0.00 because it's at 0. 5.60, 9.81, that gives us 3 sig digs. So our final answer is negative 154 meters. Okay. Let's do this one. A cyclist is traveling 14 meters per second to the right, skids to a stop in 5.60 seconds. Determine the displacement of the cyclist while coming to a stop. So again, I'm just going to bring up our displacement could also be found as V F minus VI, put the acceleration arrows there, the vector arrows, divided by 2 times our change in time. We could also say that delta D, actually, I don't even know why we need that one. I'm going to take that one out. Delta D is VI times change in time plus 1/2 acceleration times change in time squared. Okay, so which of these are we going to use? We have an initial velocity, 14.0 meters per second. It skids to a stop in 5.6 seconds. So that's our change in time. And because it's coming to a stop, our initial or our final velocity is 0 meters per second. So the formula we're going to use is not this one because we don't have we don't have an acceleration. So we're going to use this one up here. So change in displacement equals our final sorry, that should be plus, not minus. Final velocity, which is 0 meters per second, plus, and our initial velocity is 14.0 meters per second. And again, this is to the right, so that would be a positive value there. And we're going to divide that by 2, and we're going to multiply it by our change in time, which is 5.60 seconds. 0 plus 14 is 14. 14 divided by 2 is 7. I'll just put it in here as 7 meters per second times 5.60 seconds. So 7 times 5.6 is going to equal 5.6 times 7 is going to equal 39.2 meters. We have 3 sig digs in our final answer anyway, so we don't need to do any rounding. And there we go. Okay, this one, I've identified the variables for you, so I'm going to give you a chance to work on this one on your own. I'm also going to let you do this one on your own. Again, you are given what the different variables are, so please choose the appropriate chemical formula, or not chemical, the formula, the equation, correct equation to use. And so just kind of go through all of these. I'm going to show you, I'll just show you the work done on this one, but I want you to work through it and then maybe check as a part of your, as you're doing your homework, just give it a quick check to make sure that you have done it correctly. So anyways, that is all I have for you on this lesson today. So again, go over everything, make sure you understand everything. And if you have any questions, please ask. All right. See you in the next video.